I think we're going to go ahead and get started. This is Brad from Motion Media. Just a couple of things real quick before I hand it off to Kalina. If you have any questions or anything, if it's something that I can answer, go ahead and chat it in the chat box and I'll answer it as they come in. If not, if it's something that I need Kalina to answer, then we'll wait till the end and she'll go through all the questions and answer everything. But otherwise, that's basically all that I have to say at this point. So I'll go ahead and pass it off to Kalina and we'll get started.
Thank you, Brad. Hello, everybody. I hope you can hear me well and see my screen. This is Kalina from Chaos Group, and I'm very happy to be here presenting VRay for MODO. Like I just said to Brad, this is a wonderful opportunity because this is the first time ever we are showing the official version of VRay for MODO. This is the first presentation, and I think the last one was last year at SIGGRAPH where we announced the beta version. So unfortunately I cannot see your faces and I can not know which one of you have tested the beta version, what kind of experience you have with VRay and VRay for MODO. That's why in this presentation today I'll go over everything that we have time for, of course, but basically what is VRay for MODO, how it is integrated inside its MODO user interface, and from there on what are the possibilities, from the basics like rendering and illumination to some specific features that I think you find interesting. In the end, of course, I'll give you a few links where you can get acquainted with the software, see some videos if you're interested in continuing your journey with VRay for MODO. And that is the beginning from me. Now let's go and see what is on the menu today. So VRay, as I believe you know, is a plugin. It's available for many softwares, and MODO is the newest one in the family. This is an official version, so it's out there. You can go and get it for yourselves the moment we finish here. Like I said, I don't know how many of you have tested the beta version. We have a lot of improvements from there, but the approach is the same. For those of you who are new, let's go over the basics. VRay for MODO is beautifully integrated inside MODO's interface. So it's not an additional software, it's part of MODO itself. It's an additional software when it comes that it's a plugin, but the interface, everything is part of MODO. So the approach will be native for you. Basically, it will be just a few clicks different than rendering in MODO. Of course, this is very easy to use, and the best thing is that with all of this, you have the production power of VRay integrated beautifully in MODO. So the same core engine as all of the other VRay platforms like Max, like Maya, everything is the same in MODO. And maybe some of you saw VRay for Maya or for Max or any other version, and you see some of the features corresponding here as well. This is a beautiful approach, and now since we have a unified core for all VRay versions, everything that's new will quickly appear in MODO. And since Max and Maya are on 0.3.4, which means 4 service packs have been added to the official release, with the official release of VRay for MODO, the one I'm showing you today, you have all of those features. Let's go into MODO and see that integration I'm talking about. Okay. So on top where we have the main toolbars for MODO, in the end you see 2 additional ones. Those are the render VRay and render VRay frame buffer. I'll go over the VRay frame buffer in this presentation. So for now, we'll leave it aside and go into the renderer VRay toolbar. Here you see the MODO user interface with a few additional interesting icons. On top, you can see shortcuts for the main VRay settings. The idea here is to give you an ease of access to the most used panels in VRay. So here, for example, are the main render settings. Next to them, we'll find the global illumination settings, the RT VRay's real-time rendering engine settings, and a few additional ones like render elements and specific properties, which I'll go over later today. Then, of course, the render button, the teapot, and the show VRay frame buffer button. This is if you want to have a floating user interface and you want to have the rendering window, the frame buffer, in a separate window. If you don't want to do that, and by default, you have it beautifully docked inside MODO. I believe that even in this stage, it's nice to notice that the approach is the same as the standard MODO interface, and you don't need to go out of your comfort zone to start rendering. From there on, in the right part, whenever we select something that is in a way connected with VRay, you'll see additional tabs appearing with VRay. In this case, I've selected Environment Fog, but it can be VRay Properties, VRay Main Settings, or anything VRay. If I click on the render, you see the VRay Main, VRay Global Illumination panels, for example. Those are exactly the same as the ones I'm showing you on top. Which ones you want to use, it's all up to you, whatever you find most comfortable. Okay, let's start rendering. And the first, I'll go over the main ways of rendering in VRay, and I'll start with the bucket rendering, which is the sample type adaptive. You can change the rendering engines from the main settings, and you have the sample type option. So I'll pick adaptive, which is the bucket rendering, and start rendering the prepared scene. I believe you're all familiar with bucket rendering, and the idea here is that every bucket starts rendering. When it's finished, it continues to the next bucket. This is a well-known approach, one specifically working wonderful with distributed rendering, with rendering on more than one machines, but it has some setbacks, like the fact that we have to wait for every bucket, almost every bucket, to finish, to see the final render and see the final picture. As I believe you know, this can be a bit time-consuming. However, in this way, we have a very deep level of control over the render settings, over the render quality. While we wait for just a few more buckets to finish rendering, I want to show you, when I set rendering quality, what is the main way to control the quality of rendering in VRay, which is if you go to Main Settings, just below the sample type, you find the minimum shading rate. The minimum shading rate is your overall controller of all of the subdivisions of the lights and the materials in VRay. So just by changing the number of the minimum shading rate, you can change the overall quality of your rendering. Of course, higher values will bring you better quality and more render time, while lower values will be faster, taking advantage of the quality. Our rendering is done. This one took 1 minute and 5 seconds, as you can see from the stamp below. And I think this is a really good result. Let's save it in the render history. I'll talk more about the render history later on today, but basically this is a quick way from VRay to save your images on your hard drive and have access to them later. So I'm saving the image in the render history. I've already set the folder on my hard drive where I want those images to be saved, but they're visible from the VRay frame buffer. So let's go back into the rendering engines, and the next one, which will be on by default, is the progressive image sampler. I'll just pick progressive, And in order to show you what this one does, I'll just remove the image from the frame buffer and click render. The progressive image sampler, like the name suggests, progressively samples the whole scene and it gives us the result right away. Over time, this render gets better and better and better since VRay continues to sample. This is great not only because it instantly shows you your rendering, but because you don't need to know any type of settings. It's controlled by time or by noise threshold. So if you have a strict period of time for rendering, like 10 minutes, you can set the limitation to 10 minutes and leave the rendering to go on. Whenever you're happy, you can stop it, save it, and use it. So this is a very easy way to rendering, and the results are the same as the bucket rendering. It has the global illumination control, and it supports everything supported on bucket rendering. I'll stop this image since I'm pretty happy with the quality we have. And if I compare it to the bucket rendering from the render history, you can see that the images are the same. So this is another way of rendering with VRay. One more, this is the one that I'll be using for the whole presentation today and I use every day in my workflow, is the RT. This is the VRay real-time render engine and you can power it up in MODO from the play button on top in the bit right. So I'll turn this one on. The VRay interactive render engine, the RT, also gets better over time. So like the progressive rendering, if I leave it to render, the image will get better and better over time. It supports on the CPU, it supports everything that is supported on the bucket rendering, on the progressive rendering, which makes it a full-blown production render. Not only it's full-blown production render, it's also interactive. So now I can rotate the scene and we instantly see the changes happening in the rendering window. Okay. In this way you can make changes, adjust as you go. So you can see that the result is the same as the progressive rendering. You may ask, what's the difference between progressive and RT? The main difference is the control over the global illumination. With progressive rendering, you can control the global illumination engines, and with RT, it's always brute force. You can see that the RT updates as we move. It's interactive. You can adjust your scene as we speak. If I leave it over time, it will get better and better. So we can use this one with a lot of ease. And you see that today I'll be rendering RT, and again RT. And that's why I'll stop it for now and continue to another feature of the VRay RT. Maybe you notice the stamp on the right corner of the rendering. It says Engine CPU. The VRay RT on the CPU rendering on your processor is the same as bucket and progressive. We also have the option to render on the GPU. Basically, taking advantage of your graphics card power. VRay is versatile, so it's one version, you pick GPU or CPU. On the GPU, VRay supports, let's say, 90% of everything that's supported on the CPU, but you have the beautiful power of the GPU. And I don't know if you noticed, but GPUs are fast. So all this calculating power in real-time rendering. Let's do that, and I've prepared this motorbike. It's quite the heavy scene. A lot of polygons here, very big product shot, and let's render it on the GPU. You do that by just on top of MODO, VRay start RT GPU CUDA. CUDA means this is for NVIDIA graphics cards, since CUDA is a language supported only by NVIDIA graphics cards. And I'm working on that one, but don't worry, it works beautifully on a gamer's card. It doesn't have to be high-end professional graphics card. It takes a few moments for the geometry, this is a lot of geometry, for the textures to be transferred on the GPU, and this is nothing to be scared about. But when we reach this point, from there on, you see the results for yourself. Like I said, VRay is CPU and GPU, so you can test it for yourselves. You don't need to buy anything else or additional plugins. Okay, and now we have the rendering. It's again RT, so over time it gets better. Let's rotate and check some detail. Hope it's not lagging a lot. I'm speaking from the other end of the world. And you can see the GPU rendering here. As we speak, the VRay frame buffer has a few additional tools on top. And I want to show you two of those, very useful for RT rendering, the region render and the track mouse option. Basically, with the region render, I can select a specific region of the render and concentrate rendering there. Very useful, especially if you want to browse just a specific detail or have a region render faster than the others. And another very useful tool in such cases is the track mouse option. Basically, if I turn this one on, VRay will render where my mouse is. So in this way, if you need more samples in a specific part of the image, or you want to see the detail there better, you can say to VRay, hey, render around my mouse. And especially in such a noisy stage of rendering, I think you see this happening on your screen. And you can, of course, turn it off from the same button, and VRay will continue the rendering as before. Sometimes I even use this when I need more rendering in a specific region and I want to say, okay, I'm happy with the image, just a little more samples here. This is just an example of a different approach. So this is for the GPU, and let's stop this one and continue with the other features. I started speaking about rendering and missed to show you the slide. So we got over VRay 3.4 core, bucket and progressive rendering, and RT CPU and GPU. Two additional interesting things you see here on this list are the VR rendering, virtual reality rendering, which is very easy to achieve in VRay, and basically the idea is straight from VRay you can achieve an image ready for Oculus Rift or Samsung Gear or any other virtual reality platform. Since those images are quite high-res, I'll show you a quick pre-recorded video showing how easy it can be done. Basically, the idea here is that VRay has two cameras suitable for virtual reality, the spherical panorama and the Cube 6x1 camera. The spherical panorama creates a sphere around your camera and renders from there, while the cube creates 6 images, top, bottom, and sides. All of this is beautifully combined with the stereoscopic option, allowing it to render the blue and the red channel you need for 3 dimensions in virtual reality. And this is just an example of an interior rendering and how you can see it from an Oculus Rift device. So this is very easy, just a few clicks, additional clicks in VRay, camera type, stereoscopy on, resolution, and render. From there on, you can save the image and just copy, paste it into a virtual reality device. Yeah, it's that easy. No additional software, no nothing. And another thing is distributed rendering, which is basically the option to render on more than one machines. The idea here is you have render nodes on those machines and you use their power to finish your rendering quicker, of course. If you want to know more about distributed rendering and how the licenses work, how you can create your own render farm, I think you can contact Motion Media and they can give you more information on that. Okay. And I think those are the main highlights when it comes to rendering. Let's go over the basics and continue with illumination. For illumination, VRay for MODO has support for MODO lights, which are automatically transferred into VRay lights. We have the VRay Sun and Sky system, which, as the name suggests, is the representation of the real world sun and sky. A few ways to calculate your global illumination, optimized into specific cases, and all of this is connected with the physical camera, which, as the name suggests, is basically a DSLR camera, a real photo camera, transferred into 3D space, which makes it very easy to control, especially to those of you who are familiar with photography and work your DSLRs. Okay, let's go and check those lights in VRay, and just a quick notice, why is it so important to use VRay lights? Basically, VRay works physically based, so VRay lights are based on real-world lights, and VRay materials are based on real-world materials. So to get the real reflections, refractions, diffuse, the best way to do is VRay light combined with the VRay material, since they're created to work together, to work in a beautiful symbiosis, resulting in accurate materials. So I'll open a scene better demonstrating that. And start the rendering. Of course, we'll use the RT just so we can see the results instantly. We have our camera set, and I'll go into perspective so you can see the light setup. For the main highlights, we have the aerial lights created from MODO, basically the standard approach. Add item, lights, and here we pick aerial light. From the moment we created, okay, from the moment we created, you can see on the far right that it has the VRay light toolbar. Here you have a few additional settings if you want to use with VRay. You have advanced control like effect diffuse, specular, normals, photon subdivisions if you want to work with photons, and a few parameters if you want to use a texture. You can basically link a texture to the light and VRay will shine illumination through that. Especially useful with the dome light with in VRay for MODO. From there on, this light works with the normal settings from MODO, So the color and the radiance are controlled from MODO. You can see that if I make it very, very powerful, we instantly see the result in the RT. Moving it around and everything else, of course, done the standard MODO way. Okay, I'll turn this one off since we don't need it for this case. And you can see we have two additional to create some highlights. If I turn those two off, basically we still have illumination, nothing direct. This is coming from the environment overrides. VRay supports the individual environment overrides from the environment parameters. This one is only visible to camera and refraction, the background. We have different texture for global illumination and another for reflections. So all of these deep control using textures as you hear, HDRI maps, constant, standard MODO nodes is accessible to you. I want to show you how you can create the VRay sun and sky. And in order to do so, I'll just zoom out the camera a bit more. Okay, I hope you notice that as I zoom out, my car becomes unfocused. It becomes part of the depth of field. In order to do that, I'll just remove the, to take care of that, I'll just remove the depth of field availability from the camera. Sorry, I clicked on the other scene. So here we have the car render camera, and I'll just disable depth of field. If you want to add VRay physical camera control, make it work with aperture, shutter speed, and so on, you can just select the camera and go to the P plus icon on top, add VRay physical camera to selected cameras. But in this case, I want to show you the sun and sky system. So how we create those? Basically, we go to add item, directional light, and we create a directional light in the scene. We position it the way we would position the sun. Okay, and go again while the white is selected on the P plus tab, add VRay sun and sky to select directional lights. On, and now this works as a sun and sky system. If I zoom in on the car, you can see how powerful the direct illumination of the sun is. The VRay sun and sky system works beautifully combined with an environment, which is the sky. So let's add the sky to the sun. In environment, I'll go add layer, environment material. Now this will be only for the background, but from here I'll go environment type, physically based daylight. This will automatically use the VRay sun and sky settings. I'll pick the sun node. And now the VRay sun and sky are connected and work together. They're very bright since the sunlight is a source of illumination with very high intensity. One way would be by using the physical camera and changing the shutter speed. But another way of controlling them would be just by selecting the directional light, going into sun and sky, and changing the intensity. As you change intensity, you see the sky appearing in the background. The VRay sun and sky works with, by default, with the newest sky model, Hosek Sky. This is the most realistic model we have. Basically, it results in a realistic looking sky, realistic looking sunsets, sunrises, and so on. So now if I change the direction of the light, you can see it changing in the artist, appearing more like a bright day or a sunset, and so on. Like this, we see beautiful, typical illumination for a sunset. Unfortunately, we don't have time to go over everything in the sun and sky system, although it's a very interesting topic. So I strongly suggest, if you have the opportunity, to go and check them for yourselves. Okay? So let's continue to the other part of the package, the materials. Okay. VRay for MODO has quite a few VRay materials, VRay textures, mostly procedural in order to give you easy way to create your materials. They work beautifully with MODO's layered editor and the schematic material editor inside. I'll go over the basics and then a few specific interesting textures like the trip-planner mapping or the possibility to create rounded edges in render time. So quickly into MODO and let's open a scene. ARCHI rendering, what a surprise. So this is just one example of using VRay materials. How we work with those? The standard MODO approach. We select the geometry, assign material, create a material, let's name it new material, and there transforming the material into change type VRay material. Below you see the whole list and you can see that there are quite a few options for materials, like the standard VRay material, and from there on we have two-sided, which is a great material for creating translucent surfaces like paper, like fabric. We have car paint material, SSS material for skin, for subsurface scattering, materials which I'll show you, hair material, light material for simulating illumination, and so on. Starting from the basics, we transform this material to a VRay material. Okay, VRay materials, VRay material, and now automatically it works like standard VRay material. This is divided into basic layer where we have the diffuse. Select the region so you can see the difference. So here this one works as a diffuse, and then we can a second layer with reflection. This one can also be controlled, of course, by glossiness. And then just below we have the refraction if you want to create transparent objects. When you work with transparent objects with refraction, affect shadows on is a good idea to have realistic shadows, just so you know. Okay, so remove the refraction part. From there on you can assign textures, basically add layer, texture. In this case I'll pick a VRay texture, the VRay dirt, and assign it as a diffuse color. By default it becomes a diffuse color. The VRay dirt is a procedural texture for simulating ambient occlusion, and it basically works with a radius and an occluded color and occluded color. I'll make the colors very bright so we see the difference. Okay. And and change the radius, since this is 10-meter radius, which for our small figure is very unuseful. Okay, let's go with a smaller value, like 100 millimeters, and now you see the blue, the occluded cover, only in the background where it touches with the other geometry. We can go invert normals, and this way VRay will position the occluded cover on top of the edges, not inside. So this is just an example of one procedural texture collect inside a VRay material, but from there on the shading tree can get quite interesting. I'll use the same geometry and apply some pre-made materials so you see the different approaches. Just buy a sign material and I pick a few from the list. Okay. So here we have this goat shader. And you can see that here we have specific textures for reflection glossiness. Let's assign a different one. Okay, the plastic shader. Little less complex setup. And we can go on. I have a few pre-rendered images that I can show you with different materials. Okay, this is glossy, translucent material in a more complex setup with a lot of dough, some more plastic with some metals, the more detailed metal shader we started with, and so on and so forth. The possibilities are quite endless. And this is one way of creating VRay materials. I want to show you a few interesting ones, and by going over those, I'll give you more information about hair rendering in VRay. I know that a lot of you use MODO for characters, and it's a wonderful platform for doing those. Here I have prepared two troll figures. I don't know if you had those in your childhood. They were very popular here. Let's render those to see the skin material and the hair material. The hair in this case is an alembic hair file loaded in MODO using the VRay proxy settings, and basically it is supported so you can work with alembic hair. For shading, the VRay hair material is a wonderful material created specifically for hair, optimized for faster rendering of hair and allowing you deep control like primary specularity, secondary specularity, transmission, and so on. Then, for the skin of these characters, we are using the VRay Fast SS2 material, where another material specifically optimized for creating subsurface scattering in characters and any other geometry that needs it. Have in mind that subsurface scattering in VRay is based on the thickness of the geometry, so working with real-world thickness is a great approach. And of course, the materials that are thicker, the geometry that is thicker won't be as subsurface scattering as the less thick, the thinner parts, like the ears, like the nose, like real-world skin. But you see the beautiful surface scattering happening here. If we change the color, we see it instantly change. And I believe, and you can see that all of this is rendered in the RT in real time, and this makes it very easy to adjust as you go. Continuing with a few additional interesting approaches and textures in VRay. Just to have a note, just to say, trip-planner mapping is fully supported, and you can have a VRay trip-planner texture for easier shading of objects, which I'll skip over since we are very short on time. And I want to show you a different one, which is the VRay edges texture. Sorry, not the VRay edges texture, the VRay rounded edges option. It's called edges texture in Max. Sorry. So now here we have this chocolate bar. I'll select a region so we see it better. And you may notice that the geometry is very flat, it's very sharp, nothing more specific inside it. And I want to bevel it. Of course, one easy way to beveling this geometry is by modeling it, remodeling, beveling everything. But this sometimes can take some time. You need to go back and forward, and you don't have a lot of procedural control. What I want to show you is a procedural way for creating beveled edges in rendering in VRay. And I've saved the image for comparison. So now I'll select the material of the chocolate, which is the chocolate bar material. Inside the shaders, and this blend material is basically the main material controlling this chocolate. So on the far right, you see the VRay Material common parameters. We click on those, and just below you see the rounded edges white parameter. From here you can specify a value for the beveling in render time. I'll go with 10 millimeters, which is too much for this geometry, so let's go lower in 1 millimeter. I think 1 millimeter will do good. So now, as we speak, VRay is beveling the geometry while rendering. You can see that the original geometry is the same, but if I compare the two renders, you can see the beautiful beveling happening in render time. This is the bump effect. So at some point of view, it may be visible, but you can see that it works quite well for most cases. So I think this is something small, but it can save you a lot of time in the end. Okay. And let's continue with things that can save you some time. Going to the next one, if you go to, okay, let's talk a bit more about volumetrics. VRay for MODO supports the VRay volume grid, which is an easy way to load OpenVDB shaders or Phoenix Aura shaders inside MODO and then render them in VRay. So all of the explosions, all of the water, all of the fire, all of the smoke can be easily rendered in VRay for MODO. Another interesting volumetric is the environment fog, which is an overall effect on the whole of your scene, wonderful for creating God rays if you have directional lights, wonderful for creating fog, of course, dust in the air if you want more dramatic feeling, and all of those are supported in RT. Let's see the volume grid, and I'll show you the exact same fire you saw in the slide. At first we see nothing, but you can see in the items list that we have a VRay volume grid created. You can create it from add item, VRay atmospherics, VRay environment, VRay geometry, VRay volume grid. The environment fog can be created from atmospherics, VRay environment fog. So now if I render RT again, VRay will render the information inside the volume grid. Basically, you create the volume grid, you load the file from the input, and you start rendering the smoke and fire, in our case. From there on, you have some procedural control over the shader where you can, for example, change colors. I'll go with the region. So you can change colors, change the color of the smoke as well. And change the luminance gradient, which allows you deeper control over the fire, and here you can change basically the contrast and the way it overall looks and feels. Of course, volumetric rendering takes some time since we are talking about sampling a lot of voxels, but you can see for yourselves that it's quite fast, especially when we see the result right away on RT. So this is the way of rendering volumetrics in VRay. And if you are interested in this one and you want to optimize your rendering time, just a quick note, you can go to VRay volume grid, and here you have enable lighting, which will enable the illumination from the fire, and this will work quite faster than global illumination when sampling the fire. Okay, and let's continue with some speed optimizations as well. And when I say speed, I mean overall optimizations that make your life easier, your rendering faster, the dynamic geometry options. VRay for MODO has full support for VRay proxies, which are a wonderful way for optimizing the geometry in your scene, making it easier, more bearable. The VRay proxies are very well connected with MODO's replicators, so you can replicate proxies and create whole armies, whole meshes. Quite a wonderful approach in MODO. We have the VRay scene exchange, which basically allows you to export a VRay scene from Maya or Max and just import it in MODO. And an interesting thing here is that when you import the VRay scene, you have full control over the materials, over the geometry, over the lights. Alembic hair support, as I said, and of course displacement support. From there on, I'll go into the VRay Clipper, which is a very interesting tool, one of my favorites, one of everybody's favorites, I think. It deserves to be a favorite. The VRay Clipper is a wonderful way to cut through geometry in render time. Without destroying your geometry, you can just cut it in render time and see the results only in the render. So this is perfect from cut-throughs, for changing the whole view of the scene, for advertising, for architecture if you want to create a building being built any way possible you can imagine you would like to use it. And the clipper is not only a plane, it can also be a custom mesh, custom geometry mesh. I'll show you this one. Okay. So here we have an engine, and let's render it. So now we want to cut through this geometry, and we don't want to remodel everything. Of course, we don't want to remodel. And what we can do is go Add Item, VRay Geometry, VRay Clipper. We see it in the items list, we see it in the viewport, and now you see that it's cutting through the geometry in render time. You can rotate this one, you can move it around, you can animate it. Everything that you want and need to do. You can have more than one clippers in the scene, and you can add an exclude list and tell the clipper basically, don't render this, render that. Sorry, cut through this, don't cut through that. And for materials, you can see that right now it is cutting with the default material, something random, but you can assign a custom material to the clipper and in this way achieve a custom color where the cutting is happening. Another easy approach when it comes to materials would be just going into the clipper, VRay Clipper Settings, and use Object Material. In this way, VRay will render the materials that it is cutting through. So you can see that where it cuts through metal, it renders metal. Where it cuts through plastic, it renders plastic. This is how it works as a plane, but we can go much more than this and make it a custom mesh. I'll just use a sphere, but it can be any piece of geometry you want to use. Okay. Now the clipper is cutting through this sphere. It's also affected by it. But what we can do is select the clipper and go Clipper Mesh, pick this sphere from the list. Clipper sphere, here it is. Now the clipper uses the sphere to cut through geometry. You can see that everything is intact, but in rendering we see kind of amazing results. So now if I select the sphere and move it, sorry, you can see that the sphere is cutting through the geometry. We can add an exclude list to this, and just by selecting the clipper, I already pre-made a folder, clipper exclude. Mine was called main exclude, but you can work with one piece of geometry or any folder. So now the custom mesh clipper is cutting only through the top and not inside. And we went through a few features. Now it's time for the final touches, I think. And for final touches, I want to show you a major one, which is the VRay Denoiser. The VRay Denoiser is an easy way to save a lot of time rendering. Just denoise the image and work with that. VRay for MODO also has full render element support. VRay render elements where you can use them later on for compositing and for deeper control. And quickly I'll go over a few functionalities of the VRay frame buffer. Okay, so let's open a scene that has a lot of noise so we can denoise it. Basically, VRay takes information for all of the scene and then working with that removes the noise while keeps the detail. In this way, we have better images for less time. The idea is that you go to render, VRay main denoise post process enable. The VRay denoise will start after the image is done rendering, or it will be after, if you're working with progressive, by default every 10 progressive passes it will denoise and continue. I don't have the time, unfortunately, to go over the settings here, but I'll give you the link to our help page where you can read more about it and understand it better because it's amazing technology. Have in mind that this is GPU accelerated, so the denoising is very, very fast. I'll show you the pre-rendered image, and this is the beauty path of the beer bottle you see in the geometry, and this is a 3 minutes progressive rendering. The denoise you'll find in the render elements VRay Denoiser. Now, this is for 3 minutes rendering. You can see this is the denoised image. This is the beauty path. I think the changes are quite visible, and the denoising took around 10 seconds after the rendering. Imagine you have to wait for this quality of rendering. Great thing is that after you've loaded the image, this one is also updatable. So you can go again to render, denoise post-process, and this is a preset mild. You can go, for example, with strong and update. A few seconds for the denoising to happen. And now you see this is much more denoised. So this is great that afterwards you can also change the denoise levels. Let me show you how this one works on a 6 minutes render. This is the 6 minutes beauty path. This is the denoised image, and this is, and we can update it to strong quality, strong effect denoise. And you see how beautifully it works and what results it gives us. The VRay Denoiser also comes as a standalone tool, so it can denoise animation, and you can have in-between frame blending of the denoising. Quickly going over a few VRay frame buffer additions. Here you saw the render history. I'll just open the separate window. So here you see the render history where you can store images, use them to compare, and so on. Then just below you have a few additional shortcuts, which are the VRay frame buffer color corrections. Basically here you have like a few very basic but quite useful color corrections as part of the frame buffer. So you can change exposure, for example, or work with the color balance to give some specific feeling of your rendering. You also have a curve and where levels, options to load lookup tables, which is very useful when it comes to working with different platforms and different color correcting softwares. So these are a few things that can make your life easier, as always with combination with the effects like bloom effect, glare effect, basically the lens effects, which you can access from the right icon. And now if I turn it on, we can have a post effect of bloom, of glare in the VRay frame buffer itself. No need to go into additional softwares. So now I'll show you a few web pages where you can check some interesting information, and we'll go into the questions. This is our YouTube channel, Chaos Group TV, and here we have a whole playlist called VRay for MODO, where you can access quite a few videos showing you the features I showed today, and quite a few we didn't have time for, unfortunately. And here is our help index. It's frequently updated, and here you can find a lot of information about VRay for MODO. And those of you who haven't tested the beta, who haven't tested VRay for MODO and interested in doing so, can go to VRay.com, MODO. Here you can learn more about it, what kind of features it has, and here you can go and apply for a demo version, or you can go to our Chaos Group webpage. I'm leaving this one here, chaosgroup.com for VRay for MODO, the top one, you can go and download a demo version if you want to test it. And of course the links for more information, docs page, which is the help index, and our YouTube channel. So 1 hour went by quickly. I think now it's time for the questions. Brad, do we have some questions, because I don't see them in GoToWebinar?
We do. I'll just read them off to you. How's that?
Yeah, okay, let's try it like this.
So the first one is there a plan to write MODO's procedurals for VRay?
Yeah, of course.
He's asking because that's the reason that they use MODO for look dev, basically, or 90% of the reason.
Of course, there is a plan to do that. We are constantly in development, and we constantly launch service packs for all of our platforms. So at some point in the future, I think it will be. I cannot give a time frame, but we are continuing to develop.
Okay, perfect. And then when the MODO lights are converted, how close are the settings for the new lights? Meaning, how much tweaking is typically involved?
Not so much, actually. By default, when you create a new light, it works as a VRay light. So from the beginning, you set it up the way you want it to look. And if you convert all the lights, basically you may need to, change the intensity or add the texture if you want to make it on top. If I understand the question correctly, of course.
Okay, yeah. That's how I understood it too, so I think that was the answer.
Okay.
Does VRay RT GPU support more than one graphics card?
Yes, it supports more than one graphics card, and you don't need to connect them in any way. If they are connected to your computer, to your motherboard, VRay will automatically detect them and use those. I'm working on 2 as we speak.
Okay, perfect. And then are there different material presets for VRay for MODO versus VRay for Max and Maya?
The way of working is the same. The only difference is the MODO approach. I mean that in one way you create them in Max, and MODO approach of creating materials is completely different. It's mostly layer-based, but the approach is the same. You have specific textures. You can add those textures into reflections, refractions, glossinesses. You have a blend material. You can add more materials inside the blend and create quite complex materials.
Yeah, okay. And then last question, how does the denoise look in animation? Are there any problems with fluttering from frame to frame?
That's the beauty of the denoiser, that if you use it in animation as a standalone tool, you have in-between frame blending. So when it denoises, it does not only denoise the one frame it's working on, it also takes information for example, the 3 frames before that and 3 frames after that. So in this way, we have beautiful animation without, any flickering. And if you want to understand more about the denoiser, you can go to YouTube, Chaos Group TV, and there you have VRay 3.4 for Maya denoiser, and you have for Max denoiser videos, where you can check the denoiser for yourselves. Basically, this is in Maya and Max, but the approach is the same. And in the end, you have an animation rendered with the denoiser. I don't know, maybe the video is lagging on your screen, but you can check this one.
Yeah, it's pretty choppy.
Yeah, but you can check it on YouTube on our channel.
Okay. All right, that seems to be all the questions.
So then I want to thank you very much for your time. Hope it was interesting, and thanks to Motion Media for having me, and hope to see you again.
Yeah, thank you very much. And in case, if you guys want to watch this again, it'll be up on our YouTube channel, which is just YouTube and then Motion Media LLC. I think you'll be able to find it easily. So you can watch it again or share it or whatever you want to do.
Great.
So, all right. Thank you, Kalina. Thanks, everybody.
Thank you so much. Have a wonderful day. Thank you.
You too.
Bye-bye.
Bye.